Okay.
Are we actually gonna do that?
What? I mean, I guess it's 134. Thank you to our sponsors.
Mhm.
GPS, XXL, with engineering and vision.
Okay, well, I guess we can get started. So,
Okay.
okay, okay, I'll just share this. Very nice. Okay, I need to go back. I don't know what slide we're starting on.
16.
There we go. Okay, so today we're just gonna be starting off with making our intake CAD now. And this might be kind of like, it's similar to the intake that we had in Wildcat 2019 season, and we might be implementing it in the future for next year's robot. So yeah, just practice intake CADing because it's a pretty common subsystem, typically gonna be intaking something, so good practice. Wait, is anything else? Okay, so for this intake, basically we're going to have a bar of mechanism wheels with omni wheels in the middle, and that's going to be motorized so that it brings the balls in. So like when it's rolling, the mechanism wheels kind of act to center the ball in the robot, and then it also just pushes the balls into the robot. And it's going to be actuated as well by two pistons on either side so that it can start inside frame perimeter and then come out so that it can bring balls in while it's at the robot. That may not have made much sense, but okay. The first thing we're going to do is download a piece of 1x1 VersaFrame from Vex Pro, save it in a folder, and then cut it to size. Also, go ahead and just make a folder for this new project that we're doing. Just, I don't even know, intake or something. So, yeah. If you need help, just look up, vexpro.com and use their searching system. We went through in a previous episode. So, yeah, I guess pause here and then in a few seconds, I'm gonna do that. Okay. This is so weird. Okay, so once Vex Pro, I'm going to look up Versa, and then click Versa Frame Stock. You can even see a little picture right there. Very nice. Oh, I should probably go ahead and make a folder, actually. Do that really fast. Dun, dun, dun. Outreach, new folder. Add class intake. There we go. Cool. Okay, and then from Vex Pro, they have a very nice system. You can scroll down. Here you see all of the different things, just like buying it, quantity, price, stuff like that. Tells you whether it's in stock or not. And here's your selection. And we're going to take the thicker version because there's a 0.04 inch and there's a 0.1, and that's like the thickness of the aluminum tubing itself. And so 0.1 is a thicker tubing, and that's what we use. So I want this right here. Scroll down, and you have to see these. So this selection right here, thickness, drawing, weight, I'm going to get CAD files. That's what I want. Scroll down, aluminum versus frame tube stock, and that's what we want. You can click preview, and it'll load. You can see piece right here, so I think I described this in a previous video, but when you get the CAD files, they come in a 59-inch piece because that's what VexPro ships you. And so when we go into CAD, we're gonna have to size it later. Go ahead and download that. Very nice. Don't that, and then grab CAD. Go to wherever your folder is. Intake and save. Oh, it's a step file. Then I'm gonna go to Inventor, because the step file, open it, go to the file. Oh yeah, I have to look at all files, and then.
Okay, we can't see Inventor.
Oh yeah. Okay, that's right, because I shared the screen. Give me 1 second. I will show you, but it's loading right now. Basically, what I was doing is I went to the file system, I saved it as a step file, then I just open that file. And remember to click all files because it'll be, when you're opening things in Autodesk, it'll look for an Inventor file. Just click all files so you can actually see the file because step isn't an Inventor file yet. And so, give me a second, I'm just gonna share my screen. Oh, here we go. There, whatever. Okay. Okay, so then it'll bring up this thing and you can just leave the defaults. Okay, it'll convert it. Bam, there we go. Nice 59-inch piece of 1x1 VersaFrame. And we use VersaFrame a lot in FRC because it's a really convenient piece. They have holes lined out in the middle so that you can attach gussets and attach pieces together really easily. All the holes are already there, and it just makes assembly much faster, especially if you don't have readily available fast machining tools to do that. Okay, back to the PowerPoint. Roller bar gusset. Now we're going to download a VersaFrame bearing gusset from Vex Pro, same site, save it, same folder. Basically do the same thing, but it's called a VersaFrame side bearing gusset. Obviously, for an intake, there are multiple ways to create it, but this is what we're going to do. Okay, obviously just pause the video, gotta do that, and then come back. Okay, now I'm gonna do it. Very fun. Can this get out of the way? I just cannot see. I don't know if that's gonna move or not. Yes, okay. So, I think it was side, okay. So, VersaFrame, they have just a whole section for all their gussets and mounts. So you can just VersaFrame gussets or brackets, whatever, it'll take you to this page. And we want the side bearing mount, which I think is this. And if I want, I can go to the CAD files. And even if you weren't trying to download for CAD, it's still useful if you go down here, because if I go to side bearing gusset, I can preview it, see if it's what I want. I think that's the file I want, right? So yeah, I'm going to download that. Same place, and do the same thing I just did. Convert it. Yeah, there we go. Oh, I mean, do I have to save it? Okay, I don't think you have to save it because I think it automatically creates a new file, but I mean, it's always good to save just in case. Oh my gosh. Okay. 775 motor and motor mount. Now we're going to download the motor that's going to be spinning the entire bar and the mount for the motor. Oh my gosh. Okay, so when this moves, I don't know if you can see there or not, but it's just Zoom meeting stuff being annoying. Okay, go here, and if you look up Versa, because if you just look up the motor, it may not actually give you your like. If I just look up 775, then it has the motor, but because the 775 Pro page itself doesn't like have any gearboxes connected to it, it's not actually that helpful. But because Vex Pro is smart and they know that like if you're buying a Versa planetary gearbox, you're probably going to be using motor with that. So if I go to the Versa planetary gearbox, they have a lot of kits, and they know. So like for example here, hex output Versa planetary kit, and they have all this selection of the gear kits, and you can just buy motors along with it. If you can look at the instructions, but there's a lot more stuff because when you get the kit, you have to assemble it. It usually doesn't become pre-assembled, so they have a lot of different things in here that help you specify that. Oh, okay. And if I go scroll down, they have example gearboxes, which is basically just like as if you bought a kit in their system here, they have finished gearboxes. So, Jonathan, should I get V1 or V2? Doesn't matter.
Do V1.
Okay, so I'm just going to preview it. That's exactly what we want. When we do electronics, we typically get a connector piece that goes onto here, which we can buy here. But for CAD, we don't really need that. That's not going to do a lot. But just know that like when we build the actual robots, we typically have another piece here that helps Thomas do his electronics, makes his job easier, or just the electrical in general. And yeah, this is what we want. This is the vertical planetary gearbox, and this is the 775 motor on the side. Download that. And obviously, if you're using any other motor, then they also have these here. But our team typically uses 775s or sim motors, or now Falcons. And just download that. I think it did. There we go. Wait, I forgot. If you didn't pause, you can go ahead and pause, but like whatever. You know. Basically, anytime I go to a new slide and I explain it, just pause before I actually do it, because I'm going to go ahead and do it. Open. It's planetary. Convert the model. There we go. Look at that. So amazing. Okay. Go. Now, mechanism wheels. I think we actually found 2-inch ones. So like, there we go. 2-inch wheels.
Jacob,
Yeah.
get the motor mount.
Oh, yes, that is right. Okay. I also forgot the motor mount. Thanks, Jonathan. Motor mount. Let's see if I just type in motor mount. That's the pieces. Yeah, it's here. And then, so this is also just a bunch of pictures. And I think, yeah, if you click on the picture, it'll tell you exactly the piece. And this is actually what I wanted. I don't even mean to do that. But here, yeah, this is the piece that we want. And it's our vertical planetary side mount. And basically it mounts the, so here I can go to that. So, oh my gosh, I'll go through that later. But basically there are these holes that are on the side of the vertical planetary mounts, and we screw into those holes and it goes on into these holes on the side so that we can mount it off the edge of a VersaFrame piece, which is what we're doing. Okay. VersaPlanetary side mount. Yeah. CAD files. There we go. This is right. Yep. Man, it is raining. I don't know if you guys can hear that. It's very loud for me. Very nice. Actually, just so that we can find like weight and stuff later, I'm gonna go ahead and change the material of this. You're actually, okay, shouldn't have done that, but go ahead and change the material of it, pause now, whatever, and it's definitely didn't see what I just did, but change the material to aluminum. Okay, here we go. Yeah, aluminum, wow. Okay, I'm also gonna do that for this. I have to go save, I have to do that. Very nice. Just save these. And then now I'm also going to, on this file, as you saw earlier, I like clicked on something and it actually just like moved it out because it's not really constrained together. So I don't know, but unless it's like really difficult, I'm gonna also go ahead and constrain this piece together so it doesn't like, there aren't pieces flying everywhere when we're constraining it later. So if you want to pause, what? Yeah.
Instead of doing that, quick and easy way to do it, just ground the entire assembly instead of having to constrain.
Oh. It sounds kind of sketchy, but whatever.
Yeah.
I mean, I guess it works. And so,
Wait,
okay.
oh no, wait, you
Does
just
that work?
ungrounded it. You
Ungrounded?
gotta,
Oh,
yeah,
because
you
the line's
gotta
already
hang it
grounded.
off. Yeah.
Yeah. Okay, so basically Jonathan was telling me is that even though I selected everything and I clicked grounded, there was like one of the pieces when we got the assembly automatically was like Autodesk grounded it. And so when I tried to ground everything at once, all it did was unground any pieces that were grounded. And so I had to click it again. And as you can see, all those pins showed up on all these files, letting me know that it's grounded. So I can move anything around. And so basically, because like I know that I'm probably be attaching anything else to this assembly or really ever moving these parts around, it kind of is like interesting to do it, but it's definitely the fastest way to just wherever the parts moving around, just ground everything. And then it'll basically relative to like where they are now, as long as they didn't like move anything, which I mean I did, but I undid that action. But as long as didn't change anything before I grounded it, it should stay exactly how it was. And so now if I try to move that middle piece, it won't do anything because it's grounded. Very nice. Okay. Oh yeah, good mechanism wheels. So this we're going to use wcproducts.com, and they're the 2-inch mechanism wheels. And I think there are a few kinds. I don't think it really matters that much. But yeah, just go ahead and do that. And pause and come back when you're ready. And the times I'm going to display down here are our like recommended amount of time for how long it takes. So like if you're still trying to figure it out by the time it's been like 4 minutes, then you should just come back and watch me do it. Okay. Go to wcproducts.com. Don't even look at that. There you go. Gonna look. And this looks really weird. Okay. This is what I want. All right. So this is mechanism wheels. And click it. Gives me similar to Vex Pro. Gives me all these different quantities, different pieces, availability, all that stuff. Very nice. And we're gonna get wheels that look like this because these are the only 2-inch wheels that we can find ideally. So yeah. Drawings. And actually, I don't know if they're, I mean, I guess like if we were to get it right now, I'd probably take the Neutron ones because those are in stock. So I'm just gonna download this for now. But obviously when you're making the actual CAD later, you might want to look into the specs of that and that can help you make a decision. I'm just gonna change that. File, open. Oh my gosh. That's not, I mean, as you can kind of see, it's right, but it's like, what do I do?
It's a composite. I don't know. Some files, when you download them, do that.
Mm-hmm.
So
I'm gonna try
you just right-click on composite and then see what you can do with it.
repair bodies. I think that's what you would really do. I didn't do anything. Okay, never mind. It doesn't work.
Oh, no.
I'm gonna try to download the other one really fast. This
Yeah.
one, the normal one. So not Naruto. It's not Naruto, but I'm gonna call it Naruto. Okay. We're gonna try it again. Because preferably, it'd be nice if we could get a full assembly. Because this is
That
gonna
was
help
the
us that much.
same file you just opened.
Oh, yeah. That's right. Oh, man. Oh, just a bit. Yeah. Okay. There we go. Wait, this would be better. Yeah, because it's solids, not just the
But yeah,
surfaces.
take off surfaces. Like uncheck it. Yeah. And wires. And that may work. Who knows?
Maybe. Well, because, I mean, sure, we'll try
Yeah,
this.
I think.
It's gonna be kind of weird, because I don't know.
Hey,
That
there we
works.
go.
Yeah.
Yeah.
Okay. Maybe not the Naruto wheels. Okay. But there we go.
Man.
There's our CAD file. I mean, okay, obviously in CAD, we don't like, I can't just spin these wheels, but you know how mechanism works, so it is fine. And it only really matters in terms of like the distances between things. It doesn't really, like the fact that this spins or doesn't spin doesn't make a difference when we're just CADing. So save that. And very fun. Omni wheel.
Wait,
Wow.
the
I mean
left
2-inch
one.
ones.
The
What?
left one. The left.
Oh yeah, that's right.
Yeah.
Because we need mechanism wheels, we gotta have two. So this one is the right hand wheel. So we need the left one as well, because both sides. Dun, dun, dun. Yeah. I should rename those. Yeah. Because that was like kind of hard to see which one was the right or left. When I say it, I'm gonna rename it. Oh, okay. That looks good. Oh, wait, why does it look kind of different? Whatever. That's kind of weird. Oh, why is it? Okay. Oh, I should have.
That's weird. The left one downloaded as an assembly, and the right one downloaded as a part.
Huh. Oh.
So that's why.
Oh yeah, it did. Wow. Wait, did I just like throw all those files into that folder? Wait,
Yeah.
I'm gonna check that for a second. Okay. Oh yeah, there's like all this stuff in here. Okay. Mechanism. This is okay. This is really odd. I don't know why there are like different kinds of file downloads. Okay. I don't know. Like, wait. Oh my goodness. This is okay. I'm gonna do. So I'm just trying. I would try to sort through this, but I guess if you know what the files are, then you can just know like when you're coding not to like use those kinds of files like when you're assembling things. So as long as you know like what you are trying to use, then you can. I'm also gonna go ahead and delete these step files because I already converted them. And it's just kind of like cluttering the folder. So yeah. I know the step files because they're not like the 3D option right here, like the part icon or the assembly icon. And honestly, I'm just gonna leave it because I want to mess something up. Okay, so yeah, here is our two mechanism wheels downloaded. That's gonna bother me. Oh well. Okay. On the wheel, I would hope they have a 2-inch one as well. Okay. Oh yeah, go ahead and do that. Pause, obviously, and then come back and download and watch if you don't understand. Okay. I mean, that makes sense. And then Omni wheel as well. Oh, yes, 3.25 Omni wheels. Wow, that's rude. Okay. I feel like I've seen. Is that really 3.25 inches?
You can buy them on Vex Pro.
Do they have 2-inch ones?
Yeah.
Okay. I lied. We're gonna go to Vex Pro. So go ahead and pause now and look for Vex Pro. Oh my gosh, I don't know I did that. I think I just clicked like some weird video from on Vex Pro. Yeah, I did. Okay. Okay, so basically the main websites that we're probably gonna use, like it's very unlikely that we buy something that's not AndyMark, Vex Pro, or McMaster-Carr, basically, or West Coast products. Those are like basically the main websites. West Coast products every once in a while, but those are like the main websites that we buy almost everything on. So if it's not on those websites, then kind of be careful buying it. But yeah, and 80/20 actually. I like we also do 80/20. But I think that's pretty much it. Okay. Omni wheels. Do they? Oh, they don't. Okay.
I think it's like, wait, go back to Vex Pro. I'm pretty sure it's an
where is it?
FTC product. So like if you type in, I saw that like right before this thing. No. It's like type in Omni. That's so weird. There's like a FTC thing that you could click on, and then I don't know. Maybe I just saw that. That's
Okay, maybe we can go to
oh, it's
Motion.
because you're on Vex Pro. Go to V5.
Oh, because it's like an
It was on
actual
one
like.
of the red ones.
Oh.
And then try to search for like
Yeah.
Omni.
The only thing about this is they're probably not
Half bore.
X,
Yeah.
but
Hmm. Oh yeah. That's a Vex part.
yeah.
That's probably where I saw. Never mind. I guess we'll just have to get like a regular. We could get like a regular traction wheel. You know.
Oh yeah. We don't necessarily need Omni wheels for this. We can probably just have a traction wheel in the middle. But yeah. So as you can see, our plans did not really work out there. So basically, the only Omni wheels that we can find were the 3.25-inch wheels, and we would like smaller wheels, but if we can't find that, that's okay. I saw other Mechanim 3.25-inch wheels earlier, so we could either just do all 3.25-inch wheels, or we could just not do an Omni wheel and have some other kind of wheel that we can't find in 2-inch. So actually, for ease, I'm going to go ahead and do that. So go to AndyMark and just find I guess I'll do like a compliant wheel. It's fine. Just
Oh
have.
wait, no, Jacob. Sorry,
Mine?
I saw it it's on AndyMark. My bad. 2-inch Omni.
Oh, you did find one?
0.5 hex score. Yeah.
Never mind. Okay, good. Let's go to
Sorry.
AndyMark. AndyMark, and yeah, I think Jonathan's like looking at stuff like while I'm doing this, so that's fine.
Yeah. Well, I saw it earlier, but I forgot which website it was on.
Oh, okay. Omni. Oh, look at that. It's heavy.
Yeah, it's scroll down. It's the green one.
This one?
Oh, all the way to the right. Oh, you missed it. Go back.
X4.
Or, yeah.
That's nice. Oh wait, why are there two?
That's 0.275.
Yeah.
Left.
What? This is
Oh,
gonna be
that's
X.
14 millimeter. Go back.
Oh my god.
0.5x.
Yeah.
There.
There we go. Okay. I think there's like yes, I think if you go here, this is probably a better way to do it. So if you go to mechanical and you go to wheels. Okay. Wheels, Omni. It'll just give you like the whole selection. That's probably there we get to it. A 2-inch, half-inch, X4. And we currently use half-inch X4 just because that's the easiest way to actuate things, because you can just put it together and then it's just linked to the hex shaft and it really easily rotates. Well, I think some teams use circular bars and press fit things, but that's harder assembly. So that's why I typically use half-inch X. Okay, half house right here. Okay, yeah. Get all those files. There we go. And because I deleted the other set files in the folder, I mean, yeah, this is the only set file there, so it made it easier to find. Oh my goodness. Ooh, look at that. This is save as, honestly, why is it multiple names? Wait. This one, okay, 3951. So I'm only gonna have the 3951 there. There, save. Okay. There we go. Now, last thing for today. This is like a lot more complicated. And so now that we have almost all the parts that we're going to use besides the pistons, which we should the pistons we can't buy yet because we don't know the size specifications or things like that we'll want. And that's like the same reason we didn't size the first frame yet. And so we're going to make a sketch that's going to model the intake so that we already know like all the sizes of everything we need before we go ahead and actually like size things and put it together. So in this one, you're going to create a sketch, and the ball has a 7-inch diameter. It's not 7 inches. Are we going to do a 7-inch diameter ball? Because this year it's like, oh wait, no, it is 7 inches. I am just being crazy. Okay, that is right. Okay, and 1/2-inch compression into the ball. So that means that when the actuation goes down and it's outside of the intake, oh my gosh, outside of the robot, like the frame perimeter, we want the height, like the lowest part of the wheel, to be 6.5 inches off the ground. And that will have a 1/2-inch compression into the 7-inch diameter ball. And then the intake wheels must always touch the ball. So this kind of depends a little bit more on like exactly like how you're getting into the robot and the other actuations you have inside the robot. But basically, it's basically saying like you don't want to have these wheels sticking out like 10 inches away from the frame perimeter, because that's like going to bring it in close to the robot, and then the ball's not going to be touching the wheels anymore, so it's not doing anything. So you probably want less than, definitely less than like 7 inches between the wheels and the frame perimeter. So you don't like stick out a bunch, but it also has to pass the frame perimeter. And then it also has to actuate from, so yeah, basically like how you do the sketch is like when you have the piston actuation, when the piston is in one state, the intake has to be within the frame perimeter or an edge. And then when it's like in the other state, then it has to be outside the frame perimeter. And so I think that's going to be the explanation. And you have 15 minutes to do that. I'm going to go ahead and bring up the sketch that I made for a previous CAD file, previous class, so you can see how I know what's going on. CAD class. Oh yeah, I didn't do it in mine. That's right. There we go. There's your mechanism sketch. And so this is the kind of thing I'm talking about. All I did, so for this, it's just a sketch. It's not actually a part, but I saved it as a part file. And so I've made certain constraints on it, like this is a 160-degree constraint. These are distance constraints. But this is sort of not constrained the angle here, so that like when I move this, oh gosh, it's kind of glitchy sometimes, but when I move that, it's sort of just a pivot point, and same with this. So you basically add certain constraints that will always be a certain way, like the distance of versa-frame piece or things like that, and you make it so that like when you're actuating it, you can kind of see what would happen as you change the distance of a piece. So yeah, gonna make a sketch for and then you can have the edge of the rough piece kind of similar to this, and inside, and then yeah, and that's going to be 15 minutes. So you can pause now, go ahead and do that. You can look at the sketch. Basically, we bring this down. Now this box is up, and this box kind of represents the top of the table that we made. If you want to go back, this is like the first few episodes, like episode 1, 2, or 3 of the series. If you want to go back and see how this relates to that, then you can. And then if it goes back up, now this box is back at the bottom. So yeah, okay. Pause and then come back now. Okay, so now I'm going to make a new file standard. This might take a second because I had to like kind of figure out everything's going on, but go ahead and I'm just going to give myself some room, say like 10 inches by like 2. Okay. That's a fat piece of versa frame. And then, yeah. For now, I'm going to probably make some arbitrary kind of constraining numbers because I don't know exactly how like I want to place certain things, but I'm just going to test things out, and it's kind of part of designing. Kind of make different designs to figure out exactly what you want. This one can represent the wheels. You can just make like a 2-inch wheel there. And then, okay, so this also depends on your robot, but typically, so what I did there is like, okay, I don't know if I explained this before. So in Autodesk, when you're making sketches, when you get one, like it'll, as you know, like whenever you're close to lines or similar to certain points, like a corner, then Autodesk will kind of snap to that. And also, like as you can see, there's a green dot because it's a corner. But if you're along a line and there's a green dot and like not near any points, that's because it's constraining it to the midpoint of that line segment. So that's just helpful in general. And so I'm gonna go ahead. Actually, I don't need to do that. That's not necessary. But yeah. Roads. Okay. So this is just gonna be a line for the floor. I don't even know. And then make that like 30 inches, just so yeah, the whole surface. And so for our team of robots, most of the time, it's just the verse frame piece itself is 2 inches off of the ground. And so this is representing a side view of like a part of the robot, the edge. So like this is the little edge of the robot, this is the floor, and this is like the verse frame piece. And so this is because we use 6-inch wheels that are centered in the middle of the verse frame piece, which makes it 3 inches from the bottom, and that's 2 inches off the floor. So this is for our robot. Obviously, if you're on a different team or we're just making the robot differently, then all these values might change, but that's making it typical for our team. I'm gonna have this, I guess. Okay, like it's a rectangle. The height, like 1 inch for now. Actually, I'll make it inch and a half so there's more room to make holes. Oh, this would not be constrained there. Okay. And so basically what I'm thinking, oh God, this is difficult. No, it's not. Okay, that's what I want. Why is it not? Okay, I'm gonna do this. And so basically what I'm doing is because like at first I was thinking, oh, that's like kind of like a mobile inverse frame piece. But I was like, wait, when you're constraining like the point where it's kind of rotating, then it's not going to be on the little corner. It's going to be in the center like that. So probably like that point, it's 1/2 inch on all sides. And then that inches, that inch. And I'm just going to make this, I don't even know, like, it's actually, it's kind of small. I think it's 9 inches away. Oh, that's probably a lot. That's it. Just trying to think. I'm just trying things. So I'll get 7 inches for now. And then this, so when you click on lines that aren't sort of like either just horizontal or vertical relative to like this plane, Autodesk tries to make any dimension you do horizontal or vertical. And so if you really, really wanted to, this is like kind of hard. You could do like fancy trick stuff, but that's just pointless. So what you can do is you can right click and then, so this is horizontal, vertical, or aligned. Vertical is what it is right now. That's like the up and down dimension. Be horizontal, oh no, this is horizontal. Oh yeah, because it's a horizontal dimension. Okay. If we vertical, that's a vertical dimension. And I want aligned. And what that does is it just makes like your dimension just the parallel to whatever point you're constraining. And for a line, that's really helpful because it's just the distance with a line, like of the actual piece. So it's like making a verse frame piece that's, I don't know, say 12 inches long. And then we'd probably have something over here. I don't know. Because there are a lot of ways to mount this. I'm just gonna have it be here for now and go to say there. And that's gonna kind of act as a piston. And I'm gonna have to make that point to here aligned. And that's to be something looks like, I don't know, 7 inches. And actually, we'll do 6. Oh yeah, I'm just and then I have to right click, aligned. Oh, okay. So this, I don't know the dimension yet. I can say, I'll say the downward state is like 3 inches. And so, is there, I need to think about, oh, what messed that up. So when I click here, there's like a way to make it kind of like, just tell me the distance without actually like making it a constraining dimension. Or wait, maybe if I here.
I think so. I don't think.
I might
you
just
can
check
do
the dimensions later.
dimension. Oh,
No, that's not how it works. I don't think that's how it works.
no.
So if I try to
mean,
change this distance, it'll like die. Yeah, okay. Well, no, that's here. Okay, I'd make this distance. Yeah, okay. So basically, that does not work. And so for checking that the compression that's talking about earlier, the 6.5 inches off the ground, we will just have to like check that as we go. Why can I not delete this dimension? Just like down. No. I feel like I just like
you're selected on dimension up in the constraint tab, so you have to click escape.
freaking.
There you go.
Yeah, no. Okay.
Also, one thing, if you just delete the 3-inch constraint for the piston, and then just constrain that, then that dimension, and then delete the 3, then you could like track it up and down like it's an actual like side view. You know what I mean?
Yeah, I know.
Yeah.
But I think the reason I'm making the constraint is because for the piston, that's like 2 states, so that like I can say downward state is 3 inches and upward
Yeah.
state is like 6.
Mm-hmm.
And that can work. So this is still outside the frame perimeter. And
yeah.
actually, so what I'm gonna do is something helpful is construction lines, and it's just basically like a line in the sketch that's like look right out. And then actually here, I'll show you. So if you notice when you're constraining sketches, if you see how like these lines will sometimes pop up, like this dotted line going to like where I'm clicking, and that's just Autodesk saying I'm trying to snap to this other thing that's already in the sketch. And so for example here, it's useful because like I do actually want to like it to snap to this plane right here. So I'm just gonna make a construction line that goes like there. And it's a little dotted line, and that's just gonna tell me the frame perimeter of the robot. And so I want this entire circle to be inside the frame perimeter. Yeah, I want it to be inside of the frame perimeter when the piston's up, and then outside when it's down. Okay. Okay, so actually I did realize as well that this circle is actually not going to be on the very end because, well, I have a lot of things open. I'm going to close some things. And actually I'll keep that there to refer to. And so yeah, these are all saved so I know that I can just close them out. I don't want to save that. That's weird. Yeah, I don't need that right now. So what I'm actually, oh, I didn't say that. Oh yeah, I want to say that. Oh gosh. Okay. Oh my gosh. Okay, so I'm going to is that because we're using this piece, and so yeah, so like this is a bearing mount, and so the bearing, this is going to mount on the side of the versa frame. The bearing will go in this hole, and then the shaft will go through the middle of the bearing. And so like what I had wrong here, you already pointed out, is that I'm not going to have the shaft go straight through the reverse frame stock at the end. It's actually going to be kind of offset over here towards the bottom. And so I'm going to use the measuring tool. So because that line that I was showing earlier represents the middle of the VersaFrame, and the holes are always centered. So this middle of the VersaFrame here, that distance to this hole is 1 1/8 inches, 1.125. So, oh God, I have to delete that, and I'll make a line. That's 1.125. That, oh, it was on construction. Forgot about that. Delete that. And so yeah, this button right here does construction. I'm sorry, I probably didn't point that out. But yeah, and when you have it selected, it doesn't automatically go off a bit. So when you want to not do construction lines, you have to toggle it. So back 1.125. I'm going to make this 90 degrees. And then, oh, maybe that. And then I want to put my 2-inch wheel here, because it's actually kind of hard to like sort of visualize. I have a lot of practice, but it's kind of like the wheel will be right in the center of where this shaft is on the side of the reverse frame. And these holes align with the end of the reverse frame here. If that.
Hey, Jacob, I have a question.
Yeah.
Wouldn't you need to offset you go back to your sketch?
Oh no, yeah. So like, yes, like, so basically, what John's, I mean, sorry if this is not what you're saying, but I'm guessing you're saying that like this is in the center of that piece, and so like the gust is kind of going off the edge. And right now, I'm not worrying about that because like this distance is just kind of like representing where, okay. So what you could do is you could say, oh, I want the reverse frame piece to be this dimension. If I want to do that, I have to figure out the offset of like this hole from the actual end of the reverse frame piece. But right now, for simplicity looking, I'm just looking at the end, and then I know later on that this dimension actually won't be the length of the reverse frame exactly. It'll just be the distance from whatever pivot point we use to the circle. And because the reason I'm doing it is just to display sort of like make sure the mechanism itself works, but I know that later on the reverse frame dimensions when I'm making the size of the reverse frame will have to be a little bit different. And also like down here, for example, the pivot point also won't be at the very end either, if that makes sense. Like it'll have to be a little bit inside because you can't have a bearing like, here, I'll go to it. Like I can't just put a bearing or like bushing or whatever right here. It has to be offset at least a little bit. So yes, if I wanted to leave that as the actual reverse frame length, I'd have to do some more constraining and stuff. But for now, I'm just gonna leave it like this. And so we know this is not working, and I'm gonna change this distance to 11 inches. And I'm gonna actually move this in, try 1.5 inches, a little bit closer. And then this is 6 inches. I'm gonna make that 5. Actually, I'm gonna make this 4 inches, but make this a shorter piston. Oh, that's not work. I'm trying to think. Because so this is kind of getting into some physics, but like the closer that our piston actuating is to the pivot point, the less distance it has to travel to actuate, but at the same time, the more force it has to put on the bar to move it. And it's also worse to just keep putting a lot of force in one spot, because that could also bend the frame a lot. So that depends. So I'm going to have to play around a bit to figure out how to do this. I'll just get like a big piston, actually. Actually, what I might do, is, wait, I think I can delete, actually, I don't know. I'm gonna make this line really fast. So what I'm gonna do is just add a brace frame piece right here so I can have that higher up. It's kind of difficult. This is kind of, these are things that take a long time. We're getting. Be good. Inch. Okay. And then, oh, need a line dimension there. Then here, I need a line dimension. Sure, we can just this. See, 7. Oh, I didn't constrain that yet. Gosh dang it. Okay. So, okay. So there are kind of two ways I could do this. I could do a dimension from this line to this line. That's just 0 inches. I feel like that's kind of weird. So I'm going to actually use coincident constraint. And what this does is it just allows you to yeah. So you can see in this image, it's like whenever you're doing anything in Autodesk, typically if you just hover over the tool you want to use, it'll kind of show you what you're doing. And so what this does is it just takes any lines that you're messing with or points or basically whatever you're doing, and it'll just basically attach them together. So it's kind of like just constraining normally in 3D sketches. Oh wow, it's not gonna let me do that. I have to do this. I guess it'll only do a point with a line. It kind of makes sense. So it's like the point,
Jacob,
yeah.
just use collinear constraint.
What?
It's the one right next to it.
There?
To the right.
Oh, this one,
Oh,
yes, okay.
Yeah.
This is collinear, yeah. So basically, yeah, this makes more sense. So this is just the line with the, I think Jay over constrained the sketch. Why?
It's
Wait.
because of your 7 dimension. The 7-inch one.
Yeah, but
Delete that.
I should still be able to like, oh, it's being, oh, because that's actually just too long for it to actually, okay. I see.
For a triangle, yeah.
Yeah. Okay, so I'll make that 5 inches. There we go. That fixes it. Bam. Very nice. Yeah, this is hard stuff. I'm honestly not gonna expect you guys to be able to do this without right now. Oh, okay. Can I think I should be able to change this too. Oh, okay, that's right. I'm gonna make this like 1 inch. Oh, that's the wrong line. Oh my gosh. Why? Okay. I don't understand. I feel like it's something weird. It's not letting me like do things. Because
it's because of the 7 dimension at the bottom. Because you know it's like a triangle, so it already knows that distance. So
because it's collinear.
I guess if you wanted to change that.
I know what you're saying.
Yeah, you don't change the dimension.
I'm gonna delete that for now. And then I think that's the wrong line. Yeah, I think it on similar to if I do that point and that. Oh, already. Oh, I understand. Okay. 1.5 inches. I feel like I should be able. This doesn't. Okay. I feel like. Oh, because yeah. So I feel like I should be able to change the length of this triangle, like this edge, and it would still kind of, because the angle isn't constrained on any of these pieces, I don't think. Here, I should leave that for now. So yeah, so like why is it not letting me move this? Oh, there we go. Yeah. I'm gonna make this just, so we need it to be, oh gosh.
Just constrain
Oh, I think I might have accidentally.
linear.
Oh, I constrained that thing. Sorry. I think I constrained this line to like something up there. That would make sense. I need to redo this line. There we go. To dimension separately. Oh, messed that up. Trying this line to here, making it 10 inches. Okay. Now I move this. Kind of actuates. So yeah, it needs to be behind this line when it's full, and down here when it is not. And so if I make the line from there, oh, that's construction. That's hard to see. I mean, okay, so construction lines work the same way as normal lines. They just look different, but it's best to just, yeah. Okay. This kind of shows the drawings I'm about. So if I leave the dimension out of it, I can kind of just play the length of the piston and see the length it's moving. So a safe distance is like a little bit away because like when you go for the judges, you don't really want it to be like barely inside the frame perimeter, especially like when there's more wear and tear, distances can just change just so slightly, and then your robot is not even legal. So you want to have a bit of tolerance between these edges. You don't want to have it to be like just barely fitting in. So like this dimension, 5.361. If I change that to 3, oh gosh, it's not gonna change. It's definitely gonna break. Because I feel like what it's doing is it thinks that I want, yeah. It's like, I mean, I can do that. So this distance is gonna be way more than 7 inches. So I would want that even less. Like, but pistons don't work like that. So what that tells me is because it's unlikely that you're going to be able to have like a 2-inch piston when it's down and then like 7 inches when it's like up. So I'm just going to delete this. And if anyone knows our 2018 robot, is I'm going to put the piston down. Oh gosh. Constrained down here inside. So let me go 5 inches. And so yeah. And I'm gonna try again these constraints. I think, we'll try it again, but I'm gonna have to delete these because Autodesk is kind of wacky, and by that I mean like times what I want to constrain is not actually what Autodesk is doing. Is that right? Oh, I did 2 lines. I'm gonna make this. Well, there's at least a 1-inch reverse frame there. Make it 1.5 inches. What is that even supposed to be? Oh, I put an extra dot. There we go. Yeah, it wasn't already Autodesk. Oh my gosh, it wasn't already
Jacob,
obvious.
In real life, I think we should probably make that 2 instead of 1.5 because it'd be like really hard to like get that in the corner, you know? If it's
Yeah, I think it was kind of close-ish, but yes.
yeah, but
Maybe I had to do a wacky thing. So yeah, we'll do 2 inches. That's fine. Okay. So it's probably not gonna let me. Oh wow, it actually worked. Okay, wow. I don't know why it wasn't working earlier then. I thought I did something weird. Anyway, so when it's 7 inches, that is inside frame perimeter, which just means we can have a greater than 7 inches like actuation into it, but now we know that if like we're trying to find a piston later and we're like, oh, this piston goes like 8 inches, that's fine. So yeah, make it 5 inches. Now it's inside. Probably has to be shorter than that. So it'd be good. Okay, so if I get this distance, actually, okay. So this includes the radius of the wheel because it's actually going to be going the dimension is actually going to be from the center of the wheel to here. And so if we subtract an inch, that's actually like good because I just
Dude,
want
that's
to
like
go.
really good.
Yeah. So
Perfect.
yeah. So sometimes it'll work out like that, but often like when you're counting stuff, it may not be as nice and you might have to play with dimensions more. But this is actually pretty close because basically like if you subtract, it's a 2-inch diameter, 1-inch radius. If you subtract the radius, that's less than 7 inches. It's like a 1/4-inch compression, but I think any compression is maybe enough. We might want more. I don't, because if we get like, I mean, obviously 3.75, then like that will definitely be fine. And we can also, like this distance can change. So like, let's say they only had 4-inch piston, we can just mill out holes that are like a little bit closer down, like that. That also works. Let's see. So yes, because when we're milling or like for stuff like this, it's probably worth milling to get more exact dimensions. And so when we're doing that, when we get a piston length, I can edit the sketch later so we can figure out exactly where we want certain holes to be so that it's even dimensions and lengths. So that's actually too small because subtract an inch, that's 5.795. That's actually a lot of compression. I mean, again, it also depends on the inner workings of your robot. And so here, I'm going to make a ball really quickly. That's 7 inches. And so this is kind of big. So when it's going through the robot here, it's going to bring it in. And so obviously it's going through the Versa frame here. And so you could have a robot where like when it gets to here, actually, oh, because okay. But anyway, so like, oh, actually that's like kind of crucial. So basically, in every shape, we obviously have to have bumpers as well. So I actually can't have this 2 inches from the edge because I remember like
Okay. No, you can't because remember you can just put like what we have that hole in the side of the robot, like there's
no,
the
yeah,
bumpers.
but
So,
like, but what I'm saying
yeah.
is that like when we're centering the ball, like we want to have the ball obviously has to be like this has to be kind of like on the ball, and the ball has to be like basically up against the robot. So for it
Yeah,
to like
that's good though, right? It's like almost right, like the center of the ball is right and almost in the center of the bumpers.
yeah,
So
but
the
this isn't the
mechanism wheels will
bumper.
push it.
This is the Versa
Yeah.
frame. So
Oh,
it
I
needs
see
to
what you
be
mean.
yeah. I mean we can yeah.
So that means it would have to be,
That's actually
yeah, like
might be
way lower.
fine, but then this is not going to be okay. This will make our 7 inches. Like said, okay. I'm actually going to change this
Back to one.
because so I'm just going to go ahead and add the bumpers so that we have that. And if I remember correctly, I think it's like 1.5 inches thick. I'm going to, it's kind of hard to see. I'm going to add the collinear thing there. And then height, like 3 inches. Bumper height's going to be different, but I'm just going to make it a different width from the Versa frame so it's obvious what's bumper and what's not. Okay, so now we have the bumpers in, now we can kind of see what we're talking about. So basically FRC, we obviously have to have bumpers for safety and stuff, and so like when you bump robots, you don't like destroy the other robot.
It's
Yeah,
3.5 inches, by the way.
this width.
No. Your height is
This?
good. It said 1.5. Yeah. It's 3.5.
Oh wow, there's a 3.5 inches thick. That's not good. That's massive. Okay. Well, that changes things. Okay. So I don't know how I did this. Okay, it's higher up. That makes sense. Okay. So that means we're gonna play with a lot more things. I don't know what time it is. It's kind of late actually. It's gonna take a lot more messing with in CAD to actually figure out. Oh, something I didn't do is that dimension. That's probably why it actually isn't working. So make that a line.
It's constrained to the middle. Yeah.
6 inches.
So.
And if I change that, is it still?
Yeah, because it's constrained to the midpoint of the line.
Oh, that's probably why it was, okay. That makes sense. Okay. So, yeah. So what John's saying is it's going to be the midpoint, so that just means that, like, it's going to be 6 inches across. So even though I don't have, like, a dimension that says it's 6 inches, it's constrained to that midpoint that I was talking about down here. And it's basically making a 6-inch dimension without showing it, only because this piece is 12 inches. I think if I change this to 10 inches, that should be 5 inches now. Check that. So lined, yeah, that's 5 inches now. So yeah, actually, this is definitely not long enough.
Okay, I can
Maybe.
just do it. I can just like play with it on Wednesday and try to fix it.
Yeah.
Because this part takes a long time.
Yeah. This stuff we probably wouldn't just like do in like an hour video. It takes
this would
big times.
This took us like 2 days last year.
And so
It's gonna be like crazy long. Maybe we should do 3-inch reels.
Maybe that would be more helpful. And then if I make this 7 inches away, 8 inches away, and then this, I'm gonna do that, even though I don't like that.
It's gonna be cramped. Even
This has to go down more.
Yeah, that's close. Maybe make the top like 16.
Like,
yeah, and then it'll like actually like suck in the ball if you make that like 4 or 5 or something.
Yeah.
Or yeah, like minimum.
So when it's like,
oh yeah, that's good.
3, so 5, that would be fine.
Yeah.
This is good.
But then I'm pretty sure that for the piston to be,
it's like so long to.
it's gonna be like.
It's like, yeah, that'd be so hard to get inside frame perimeter because I don't even know if that's in.
That's like above our entire rim line.
No.
Oh my goodness. What if we had a retractable intake, like on an elevator, so like when that could
that's
that'd be cool.
Oh my gosh. Yeah.
I think that's all for today. I'll try to prove it tomorrow.
And so like, I mean, yeah, also things we can do is like we could make a big mountain over here and a piston to like, I guess here I'll make lines to come and grab it like from over here instead, so they can like be extended when it's down and then retract it to bring it up. And so there are a lot of other places we could put it that might make it better. But yes, when we come back kind of like a finished design, we probably don't expect you guys to just like make a whole intake over the summer, just because like that's hard, especially doing stuff like this. So yeah, this just takes like playing around with and a lot of time. And this is one of the things that takes a long amount of time when we're CADing to make sure all the mechanisms actually work well. So yes, we will be back on Wednesday. And I mean, if you guys want, even you guys can also like plan out the sketches, because I mean, obviously kind of led by your imagination and money, but yeah, just your imagination. But yeah,
especially in this club.
Yeah, and so you can play around with different mounting points for this part of the piston, different points on here, different heights for this. There are a lot of things you can do to just play with it and figure out how you can make this work. But if it wasn't obvious earlier, well, the ball kind of has to be against the bumper, and then when this is down, it has to be touching the ball, and then when it's up, it has to be inside frame perimeter. And that's basically the only specifications. And so, yeah, there we go.
All right, so I guess we'll see y'all on Wednesday with a finished sketch, and then we'll probably like start constraining the assembly.
Yeah, I'm also gonna post this, like just this one, in case you guys couldn't make this yourself. So I'll post this so you guys can also play with it. So
well, there's also no one here, so
yeah, that's fair. But yeah, if you're watching in the future, it'll be like if you're watching the video, it'll be in our Slack channel.
Yeah.
But, okay.
All right.
Yeah.
Guess we'll see y'all on Wednesday.